Hey, welcome to calculus class. This is our first video and it is really just some review of algebra pre-calc stuff because we're going to be looking at lots of exponentials and logs this chapter. So just as a quick review, logarithms sort of look like that, exponentials look like that. Good, we're done, right? Not quite. I do want to point out a few things. They are inverses of each other. Some very important stuff to know there. Inverses, meaning if I reflected them across that line, y equals x, one graph would turn into the other. While there is one distinctive point on logs, at 1, 0, on exponentials it's 0, 1. Unless there is some kind of transformation, you know those points are going to be there. Now, because they're inverses, I'm going to point out that the natural log, that's log base e, of any exponential base e is simply the original variable, number, value. If the bases match, base 3 and base 3, those inverse functions, whatever one does, the other one will undo. Same thing for base 10. By the way, if you don't remember, a common logarithm is a log where you don't need to put a number down. It's assumed to be base 10 if nothing is written there. Just like ln is assumed to be log base e. All of this is in your notes, and your notes are on the topics page for chapter 5. So please take a look at that. It has all the same rules I'll be going over. By the way, same thing applies if you have an exponential power of a log. As long as their bases match, they will, and this is the only time in math I say cancel. When you have inverse functions, they really do sort of cancel each other out. I'd be left with 4x plus 2. Or if they're both base 5, I'd have phi, or sine of theta. So knowing that they're inverses, that's a good start. And here's one more important thing. Whenever you take the log, any log, I don't care which power it is, if you take the log of 1, what is it always going to be? Log of 1 is always 0. For almost any logarithm that you do in calculus, you can use a calculator, or they don't care. Your answer might just be log base 3 of 4. You won't know that answer. Neither will I, and yes, unless we use a calculator. Huh. But the one point you need to know is, if you ever have log of 1, it's going to equal 0. Remember that. So here's a number of different logarithm rules. These are not calculus-based. These are simply algebra. And hopefully you've had them before in either Algebra 2 or Pre-Calculus or both. These are also in the notes on the portal. Look under the topics page. And that will have notes for at least parts of chapter 5, the parts that I don't have fully covered on video. So note that these are named by the product rule, not because it is the product rule for derivatives, but because you have the log of two things multiplied together. If you want to take note, these are absolutely the opposite of the exponential rules for when exponents are multiplied, or at least their powers are multiplied. So you can look through and you can compare those in the notes, but there's the quotient rule. Dividing by a value is the same as subtracting. This is the tricky one, but super important. If you have the log of something to a power, you can move that power out front. And then finally, the change of base rule, that only was necessary for people who have really old calculators or people who want to know how we take the derivative of some of these logs. That'll come in a later lesson. I'm going to look at a couple examples where I'm going to say, please expand. When I say expand, this is going to be super helpful. Please don't skip over this because it's algebra. What I want you to do is learn how to take a logarithm that looks kind of difficult on the inside and then write it into several simpler logarithms. For example, in this first one, I have two things that are multiplied. So I could write that as log of x plus log of the square root of x plus 2. But that's not the best that I can do. If I really want to make this as easy as possible, I'm going to recognize that this is to the 1/2 power. You may ask yourself, why? Why am I doing this? And the answer is, it's going to make your life much easier very soon when we're doing derivatives. Let's try the last two. Look at them, pause, see if you can rewrite them in the simplest form. However, I just added an xy down there, so make sure you include that since I wrote it wrong the first time. Shortcut here, don't forget that in this part, the natural log of e to the x is just going to be x because they're inverses. And finally, dividing